Hello, everyone. I appreciate the claps. I'm burning some Palo Santo here for good vibes, but well, welcome. Thank you. If you're watching this in the recording as well, it's just as valuable. This information is timeless. My name's Ryan. Like he said, I am a programmer, and I'm just excited to talk about pulsar synthesis. It's a little bit off the beaten path, but it's something that I think we can all grasp and put to use, whether it is implementation in a plugin for musicians and artists, or if you're a sound designer or an electroacoustic musician, if you like noise music, this is the best option you have for digital control of noise. It has very precise control of formant frequencies. And I won't say any more because it all gets into it in the video here. I'm going to play that back. Wish I could do it live, but I just want to be sure that I get everything done right. So I recorded it ahead of time, but I'd be happy to answer questions in the chat, in the Q&A as well, as we watch the video. And then I'll be roaming around. I put myself in all yellow head to toe in GatherTown. If you want to ask me questions there, I'll shoot out in the chat also my link tree. So you can find me on LinkedIn, TikTok, YouTube, whatever. You can follow me on any of those platforms. Anyways, with no further ado, let's get started. I'm going to play my presentation for you.
Hello there. My name is Ryan Devens. I am the owner and operator of Recluse Audio, and I'm here today at ADC to present about optimizing pulsar train synthesis for live performance. So at its core, what I'm trying to achieve is expressive pulsar synthesis. I'm looking to take a field that has largely been focused on interface and move that to the realm of instrument. So a little bit about me. I love riding my bike. I wish I never had to touch a car in my life. Always wear a helmet. Thankfully, my hometown, we got lots of roadways like that. I'm very into contemporary art right now. Anytime I go to a new city, I love looking at the installations of contemporary art museums, and I love the cross-sectionality, intersectionality of the different mediums. I love audio-visual works, noise music, electroacoustic, and live performance. Like I said before, I own Recluse Audio. We are fledgling, but we are getting some sales and a lot of downloads of the free stuff. We make AU and VST3 exclusively, no AAX, no VST, no VST2. I didn't get grandfathered in that license fast enough. So what are we going to talk about today? Well, first of all, I'm going to teach you what is pulsar synthesis. I think a lot of people might not know quite exactly what the term refers to. And we'll talk about the history and the aesthetics and maybe a couple use cases. Current applications, so we'll see how the software looks already, the stuff that's out there, what it's good at, where it's lacking. Going to identify the limitations, so where it's lacking, case in point, and we're going to consider them specifically as they create challenges in live performance. Then I will propose some optimizations, personal strategies that I used in developing Pulsar, my synth, to accommodate these challenges and to rise above them, make an instrument instead of an interface. One philosophy that I want to explore that kind of encapsulates all this, I've developed it throughout the process of making these plugins, particularly Pulsar, is device state visibility. How digital instruments visually convey their sonic state. So a lot of that has to do with relatability and reactivity in the visual realm to the audio settings of parameters. We'll get into that. And then I'll leave some time for questions. This is pre-recorded. I'll try and wear the same outfit too, but you can talk to me later and we'll have some question time. All right, so why did I make Pulsar at all in the first place? Well, I deeply enjoy particle synthesis. That means granular synthesis, pulsar synthesis, even micro montage where you just edit it in with like tiny little points one by one. I was sick of fixed media performances. We do channel noise at Georgia Southern, or we did while I was still attending there, and it would be an electroacoustic conglomerate, and everyone would come in, and it was a lot of fixed media stuff, and the things that it was a lot of fixed media stuff, and the things that were so common were, you know, the performance involved them adjusting faders on a mixer, which is like kind of just for show almost. And I desired an instrument that required mastery. So another thing that I've encountered with new interfaces for musical expression is that they just kind of play the right notes for you and there's no way to master them. A novice, an expert, there's no such thing. It just kind of did it on its own. So what I made was Pulsar, and you can see it down here in the bottom left. It's a stripped down, simplified means of pulsar synthesis. And then I made this for diffraction, which is an electroacoustic composition and audiovisual light ballet I did with my mentor, Dr. John Thompson. He did the visuals, I did the audio with Pulsar, and a Moog and a Brute. It was wonderful. I'm going to skip ahead a little bit. So here you can see me and Dr. Thompson tweaking the parameters as we go. And then I'll just skip ahead a little bit so you can see his beautiful visuals. All right, we'll save that. You can watch it. It's Diffraction, Ryan Devens and his music. But you can hear the Moog, Prodigy, Mr. Old 1971 or whatever, and then the Pulsar synthesis occurring at the same time. Both of those are being done in real time. Two hands, one for the slider, and then I'm using the pedal to trigger the Pulsar train. So that is very use case optimized. I built Pulsar for that performance, but it ended up being pretty usable in a lot of other settings too. I want to present a quote from Robert Moog here. When a pianist sits down and does a virtuoso performance, they are in a technical sense transmitting more information to a machine than any other human activity involving machinery allows. All right, so just chew on that a little bit. We'll circle back to that as we keep going. Let's get familiar with pulsar synthesis here. It is tiny little particles of sound. It is a type of particle synthesis. If you like pointillism, if you like even a little bit of collage too, textures, clouds of sound, it gives you precise spectral control. By controlling the pulsarette, this is what sets it apart from granular synthesis. We are controlling not only the frequency that it's played back at, right? So it can be repitched and it generates a formant frequency. It also, instead of just using impulses with an infinite bandwidth, we are using wave shapes with their own harmonic colorings. Pulsar synthesis is excellent for traversing time scales. In fact, that is how we have used it in the past. Here's a quick little demo of some simple pulsar synthesis.
So you can be kind of expressive with it. So
all right, so talking about someone who likes to traverse time scales, let's look at Stockhausen. He was doing this in an analog sense with test equipment. He would filter the impulse responses. You'll know it's pulsar synthesis when he starts drawing the line. Has a harmonic quality too. It's not, it's like 2 hertz now, but you're still boom, boom,
each
boom.
sound is longer and longer.
He's adjusting width there. He's does a nice series of lectures on his 4 criteria for electronic music, very ahead of its time. Next in the digital realm, the one who's had a more profound effect on me directly was Curtis Rhodes. He teaches at UC Santa Barbara. He wrote Microsound in 2001, revised it in 2004. I cite that a lot. He also wrote a highly cited article, Sound Compositions with Pulsars, in 2001, also very good. Let's hear how he uses pulsar synthesis. All right, so you can hear in his process, he likes to do record it, maybe improvise a little bit with his software, which we'll look at in a little bit, and then a lot of micro montage and editing just in Pro Tools or DAW of his choice. But we see the pronounced difference in a digital system where you can have like ping pong pan positionings. He likes to use spatial harmony and has his own pedagogy for that as well. Here's a quote from Curtis Rhodes. This is out of Microsound. Even with all these implementations, there is still a need for an instrument optimized with controllers for the virtuoso performance of granular textures. That's pretty much exactly what I'm going for here. This is from Microsound. So the pulsar period, this is what defines those little grains, or pulsarettes in this case. It is a period, right? And we're emitting them at a certain frequency, and that period is determined by the fundamental frequency, the rate of emission of pulsarettes. And that is equal to the period, the pulsar period is equal to the duty cycle of the pulsarette, how long that wave shape is going to run for, usually one cycle, and then a period of silence. Now, because the wave shapes and the pulsarettes are usually at above 100 hertz, they're very small. If it's 1 hertz pulsar period, but then the formant frequency is 100 hertz, it is 100 times smaller, that wavelength is, in the pulsar period. So there's a lot of silence. We can see right here the pulsarette duty cycle is the duration of the pulsarette, just the wavelength. Period of silence is that what comes after. Pulsar period is all of it together. Now, as we adjust these parameters, it kind of has a rock, paper, scissors type effect on each other. First of all, when we adjust the fundamental, let's say we have a higher fundamental frequency, these pulsarettes are going to start getting closer together. And intuitively, the silence period is shorter. So they start to blur a little bit more. Now here we have an increased frequency of the formant, which means it is read through faster, has a higher phase step, larger phase step, and the wavelength is shorter. I should say the period is shorter, and the period of silence after that is longer. As we lower the formant frequency, the period of the wave is longer, therefore the silence period is shorter. Compare here a higher fundamental, this should say, to a lower fundamental. We'll correct that. Another thing to notice is sometimes we use width in pulsar synthesis, so it won't just be one individual cycle of a wave. It could be multiple cycles. This will affect the silence period as well as the pronunciation, I guess, the emphasis on the formant frequency, because as we have continuous cycles of a wave at a given frequency, that becomes more dominant. Whereas when it's only a single cycle, fundamental is a little bit stronger. Enveloping of the pulsarette is very important. We could have an exponential decay. This is reverse exponential decay. This is FOF, rectangle. And I'll invite you to look at the right side of the screen here, and we can see the spectral response of a bunch of pulsarettes with sine waves. So it shouldn't be this wide. Why is it this wide? Why is it expanding up harmonically? Because of the envelope shape. At this time scale, the envelope is as much, and if it has just as much effect as the wave shape does. And just like going from if we compare this to a sawtooth wave, the exponential decay, we see no gaps in the even harmonics, whereas the rectangle, like maybe a square wave, does have odd harmonic or even harmonic gaps, and it emphasizes odd harmonics. With Gaussian, it does still have an effect on the spectrum, but it's not as pronounced, and I thought that was better for cognitive ease for the performer. All right, I would be remiss if I presented at ADC without showing some code. Now, you'll find that with pulsar synthesis, it's really wavetable synthesis. So if you have a means of doing wavetable synthesis already, it's very easy to plug it in and do pulsar synthesis. It's reading from a wavetable, right? In my case, a wavetable vector. We can see right here that as it gets above M sample rate divided by fun frequency, which is the pulsar period, we are going to generate a pulsarette, and we're going to update the period, which is passed to the pulsarette, and reset the phase. And then we just write to the buffer that we passed in. This would be from the process block in your plugin. It's not unlike having several synth voices. We go through and find the first one that is free, and then we generate it. Now here, it's also like a synthesizer. We only write to the buffer if it's actually running. Otherwise, we just break out of it. Here in Pulsar, we can see how it is related to the wavetable. This gets a next sample from the wavetable vector, and then it keeps track of how long it should be running by measuring the duty cycle. And then we increment the phase, we set it to running if it's, or we stop it from running if it is above the length of the duty cycle, and we increment. This is still sample by sample. It does not have a phase step. That is, it's scaled by frequency only in the wave vector, which we set right here and generate Pulsar. And the duty cycle is either one cycle, so the sample rate divided by the frequency. That's how many samples would be in one cycle at this given frequency. Or if we have a width setting that gets us above one cycle, it will go with that. So maybe it does go on, through whole or partial cycles, and we need to account for that when we are measuring our incrementation. So let's take a look at the current application for managing microsounds, particularly pulsar synthesis. We will look at a couple granular synthesizers too. Well, we got to mention this Pulsar generator from Curtis Rhodes in 2001. He still uses this, and it's only on Mac OS 9. So I wasn't able to use this actually, but he describes it in detail in several articles, and I read the manual. And it looks nice. It looks very good for how he uses it. It gives precision control with these envelopes. His software, we'll look at one other that he had an influence on, have very variable ranges. You can see the formant frequency here and the formant frequency here, even just by the lines in it. There's a smaller range within this window. We have a window and an envelope for each of the parameter trajectories. And I believe any one of these windows can be converted into a wavetable for the Pulsar. This is very mouse clicky, is how I would describe it. It does allow for improvisation, but not very easily. It doesn't seem to easily map with MIDI. I'm sure it's doable. And it's a little tough to perceive everything at once, but it gives you a lot of very precision control. And you can draw in wave shapes as well, which I don't think is useful, but I could answer that in the discussion afterwards, because you don't know what the harmonics are going to be. You don't know what the spectrum's actually going to be. It'd be better to draw in kind of like how Ableton handles it in some of their plugins. This is something you can trigger and then record, and then you bring that into the DAW. It doesn't work, and you can use Jack, you can route it, but it's not a VST though. It's a standalone application, which is the case which is usually the case I've found for granular software. Here we see Emission Control 2. This is under the watchful eye of Curtis Rhodes. It was released in 2020, spearheaded by Rodney Duplessis and Jack Kilgore. Forgive me if I mispronounce the name. This is based on Emission Control 1, which is a classic synth, of course, from Curtis Rhodes, but updated for modern use and modern operating systems. We see this wide range of mappable modulators. LFOs. There's actually no envelopes in this, but you can have them rise, you can have them fall. So I really like that aspect of it. And again, we have scalable ranges, which we'll get into later. This is pretty effective and very clever. Like, it doesn't take a lot of windows to accomplish very, very complex setups. iPulsar, well, it's in the name. I got to include it. This one is iPad only, so it's a very tactile thing. Another one is Borderlands 2. I didn't include that in this presentation. That's another iPad interface for granular synthesis and pulsar synthesis. Now, this allows you to interpolate between the waves that I actually use, from a sine to a square to a sawtooth. It gives you good control of the envelope system. It gives you good control of grain parameters. And it is part of a category that I would call the keyboard pulsar synthesizers, where if you play a note on this keyboard here, if you play a C, and we'll call it 120 hertz, it will play octaves below that. So it will play an LFO frequency or a rhythmic rate, but it would be based on the pitch of the note that you're playing. And you can adjust how many octaves to go down. Another one, similar to that, is Nuclear from Hamburg Audio in 2015. Now, this one does the same thing with the keys. So if you play a key, it'll play it octaves down, but it gives you control of that right here with the global octave parameter. So this is, you can use it just like a regular synthesizer too. It works pretty well. Now, God bless them. They're the only other people, I swear, that are making a VST for Pulsar synthesis. You got Granulator from Monolake, the Max for Live device, but that's Max for Live. That's not quite the same thing because it is no longer, you can't make plugins with that. Too bad. All right, so let's identify the limitations within these fantastic pieces of software. Now, at first, I got to say, I love these. I selected these because they're my favorites and because they got the closest to what I was looking for. But right here, I'm going to list the things that it kind of hindered me when I was trying to use them for diffraction, that piece I showed at the very beginning. All right, so one of the limitations, and this might sound kind of like heresy, is the envelopes in the mod matrices of pretty much every synth I've ever used. They choose to be mutable and not musical. Catchy, right? It's alliteration. They're mutable, not musical. They allow you to assign anything to anywhere with any type, and it's like, I remember I applied to Ableton once, and it was like, make this processor chain, and then you can rearrange all the orders of it, and then you can, and it'll print out cow, dog, milk, moo, whatever, or delay, and it'll do, and it's like, constantly, it's all about like rearranging and rerouting stuff, which is cool for a programmer, and you can tell that programmers make these synths. But it doesn't feel musical. It feels very programmatic, which is beautiful. I love programming, don't get me wrong. It has a detrimental amount of options. So we can see here, we have 1, 2, 3, 4, 5, 6, 7, 8 envelopes, which is great for within nuclear, I should say. Now these are like kind of small, and I don't want to say insignificant. They're visually insignificant, but they could change the whole sound of the synth. So it's not really representative of the role they play. You can't view them all at the same time. And it's a lot of envelopes to choose from. I mean, if you're using all 8 envelopes, you might have gone too far. I don't know. And especially if you pick up a preset, it's like, oh my God, I don't know what's going on. It's impossible to decipher. And overall, it automates trajectories, right? We have all these parameters for pulsar synthesis: the formant, the wave shape, the panning, the spread, and the ranges of random generation of values if you choose to include something like that. But which is ideal, right? If you're sitting and you're using a mouse and keyboard. But if you want to perform, it's not really something you do on the fly. It's like playing an RTS game where you gotta like give them instructions and then have them be executed, rather than playing a fighting game where you're like playing Smash Melee. It's like you got a frame to react. So having automated trajectories, kind of, which is these LFOs, and which is these envelopes and these envelopes here, and you're adjusting the formant frequency with those, and you're adjusting the wave shape with those, the cognitive workload becomes excessive. All right, another limitation or challenge that I found with these in live performance was parameter value representation. I felt a lot of times the state of the instrument or the state of a parameter was not really representative of itself. And I have an example here. When we have these mutable ranges, these like scalable ranges, it's as misleading as like an economist might choose to be, where they put, oh, $10,000, $11,000, and then it like, look, we doubled it, but really it went up by 10%. It can be misleading. Well, let's abandon the metaphor. Look at this. This is at 18.21 hertz, and it is completely at the bottom of its range. This is at 18.215, and it's about 2/3 of the way up. So you can see that these almost identical values look totally different. And yeah, you can look at this and then figure it out, and it's not inaccurate, and it will work right, and it's nice to be able to limit the range too, but that is misleading to when you load a preset. It's misleading if you're performing and you like forgot where you are. You got to keep track of what the scaling is for all of these as well as where they're mapped to. It's too much. Right here we have, again, these are equal values. This is the modulation coefficient for whatever parameter you're assigning it to. The range is unclear. This minimizes drastic changes, and it obfuscates the device state. Menu diving. Again, another cherished hobby of a synth enthusiast, especially if you own a DX7, but it's not ideal if you're trying to make a sonic counterpoint using just the parameters that are hidden between all these different menus. And I count it as a different menu, or I count it as a menu if it's a different window as well. So with nuclear, where each of these envelopes are under a different tab in the window, you can't play with them at the same time. Like literally you can't. Even if you could, if you had assigned the values, you're not seeing the changes happen. So here we see in iPulsar, this top right here is pretty good. They have all the grain parameters, for the most part, at your fingertips. But the wave shape is in a different menu. It's inaccessible at the same time. And so is the envelope and the width. They call it grain length, but it's really functions like width. Take a note here too. It does offer glisten sweep, which is a parameter that Pulsar doesn't have, but that's cool, and that's a good thing to ask me a question about later. If you're performing, it's just not going to be the same. You won't be able to have the, let's say, the grain length decrease while the wave shape increases or interpolates to, more harmonics. You'd have to just do one or the other, or you'd have to find some workaround of automation. Parameter association is something that I find pretty cumbersome. It's unclear what parameter is associated with what. So here I've highlighted in red, these things are the parameters that affect the formant frequency of the pulsarets. Right, so we have 4 pulsar trains running at once, which is cool, but also troublesome at the same time, because it's not necessarily that hard to just have multiple instruments, and I just want to be able to control the one pulsar trains, and you got to turn them off to do it. But that's okay, I can deal with that. However, it has a global pulsaret frequency, which then affects the scaling of these frequency parameters, which is troublesome to me. I don't quite understand the relationship. The manual was unclear on how they relate. It says, as relates to the pulsar frequency, but it didn't say, it's not a multiple or anything. And moreover, it can be changed in multiple places. So you find yourself in the position where you're just like, what is going on? Why is it not changing? Well, because it's up here as well. In blue, we see things that affect the width. So this is a blending between a classic oscillator and a pulsar synthesizer. And because one of them is continuous and it's blending with one that is discretized or pulsarized, they can blend and make it seem like a width manipulation is going on. The phase actually sounds really cool. Don't get me wrong. It allows the multiple trains to kind of overlap and then synchronize, and so it will fill out the texture and then make a skeleton of it and then fill it out again, make lush textures. The width has to do with the phase offset of left-right, so it's like a stereo width, which affects the width of the other ones. Right, so if this one has a phase offset for the left or right, and then it's going to start interacting with this one, which doesn't have any phase offset. And it's just another reason why I like to just run one train at a time. And then most of all, the interdependence of the fundamental frequencies is misleading in this. So I've highlighted, this one has the most yellow on it, or the most colors in it. We can adjust the global octave here. So this is where we could set it to not even do any pulsar synthesis at all. If we drop it down really low, it will, then when I play middle C, it'll play like 5 octaves below that, and it'll be in the pulsar frequency range. And then we can also fine tune it here, and we can also adjust the semitone tuning here. So my sweeps up, it was not very easy to do with this synth. It seems more rhythmic than anything. There's still a lot in here, though. I love this synth, particularly the micro sequencer. I would love to talk, if I had more time, I'd talk about that for a while. It does a really good job with trigger patterns for pulsarets. So you could go dot 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 dot, and it could do spits and sputters and misses and all that. But for these other parameters, and this gives very lush sounds, but it did not give me the precision control I was looking for like a virtuosic instrument. And most of all, other than nuclear, they're not in a DAW. iPulsaret, come on, why is it only on an iPad? Do I want to make music on an iPad? No, I don't want to do that. It's a toy then. And nothing against iPads. I'm not even saying they don't have the processing power. What am I going to plug it into? That's such a pain in the ass. Like, I don't like that. And for live performance, I'm not going to use the iPad. I wanted to be able to use things in the DAW. I didn't need envelopes because I can use automation lanes. I don't need multiple Pulsar trains because I can make an instrument rack that has 4 iterations of Pulsar running within it. As to why like emission control isn't available as a VST3, I don't really understand it. In fact, I was thinking about trying to port it. I know it uses the Allo lib, but DAWs are great. I know Curtis Rhodes uses DAWs, and I know most people who use Pulsar synthesis, it's going to go into a DAW at some point. So I don't understand. And I know you can use like Sound Jack or Jack Router or whatever, Rewire, but it's not, that's another step. That's another thing to open up. I want a VST3. I want an AU. And I like using Ableton. I perform with Ableton. So this to me is a no-brainer. Thank you, Nuclear, for seeing the light. Because there's a dearth of granular and particle options for VST3. That's what Recluse is here for. So let me propose a couple optimizations to you, other than obviously make it as a VST3 AU. Just do it. Just do it. There's no reason not to. I don't see why you wouldn't. You know, I mean, you got to shoot him an email to ask licensing permission, but if you release it under GNU, I don't even think you need to. So just do it. There's no reason not to. All right, moving on from that. Here's an optimization for envelopes and matrices, mod matrices. These are something that are really great about synthesizers, but sometimes are limiting in the musical sense. So I choose to limit user choices. I want to make it down to the brass tacks. It does what it does, doesn't do anything else. If you want some changing of parameter trajectory over time, go into automation lanes and do it, all right? We use gestures as trajectories. So other than, it does have an ADSR for amplitude. Okay, sorry. I wanted to be able to control how it rings out. It might as well just be release, honestly, because that's the only thing that I wanted to have, you know, automated. But with Pulsar generator, it lets you control the form and frequency. It lets you control the fundamental with high precision, and you draw in lines about how that parameter will change over time. But I wanted to just control that over time, like kind of like a MIDI latch, how you would draw in automation. Why not? Why not just make them MIDI value tree state values that you can map to a MIDI controller? You just so you get this thing running. You press down the sustain pedal to trigger it, and you start twisting it around. I don't really need an envelope for that. The envelope's up here. The envelope's in my fingers. And one thing I came to realize was I can use a glide factor to have greater control and do some more unique things with my gestures. So watch a quick little video, and it will elucidate the benefits of using glide as sort of an envelope creator. Adjusting form and frequency. Follows right along as I change the parameter. Now let's increase the glide. So it lags behind quite a bit now. It lets you sweep through a little bit slower, and it kind of trails, and it gives the instrument a different quality. And this is great. Put Valhalla frequency echo on that, and they start doing some... There's fundamental frequency, no glide. Again, it falls right away. It's like a chainsaw then. We just shifted our time scale completely. You want mutability, Curtis Rhodes, right here. I don't know why Reflections is in that. It's killed right now. I was playing with the width there at the end in the pan. All right, continuing on. Another optimization I would say is how we approach parameter value visualization. When we change a parameter, it should really kind of give us some clues as to what it's doing to the sound. I like drastic color shifts, which is why it has a stark black background. I represent ranges and coefficients this way, so let's talk about stochastic ranges here. A big part of Pulsar synthesis is random value generation. Random formant frequencies, random fundamental frequencies, wave shapes, Gives it a little noisy quality, a little unpredictability. It's better for creating clouds of particles so it doesn't just sound continuous. As you see, we can control well, let's start up here. This affects the range from which a random value might be selected. And this one's about 55%, and it's pretty big. This one's at 100%, that's huge. And then this one's about 75%, it's very large as well. And these are scaled intuitively. So for frequencies, they're logarithmic, and then for the wavetable, it's just linear. And then down here we have, you could call it the stochastic coefficient, the random coefficient. This is the likelihood that it will be randomly generated. The range from which it might be generated, the likelihood that it will be generated. The range is represented, as you can see, in the size of that bar, and the stochastic coefficient is reflected in the opacity. And if you want to know how I made this slider, that would be a great question for afterwards. It involves actually 3 sliders, so if you're curious. Strategic visualization like this makes it really easy to look at a synth and say, oh, wow, this is a really random setting, or, oh, this one's has no randomization at all on it. As well as sneaking in the wave shape in the background just makes it aesthetically appealing and informative. Menu diving. How do we handle menu diving? Because we want to provide options, but we don't want to overwhelm people, right? Number one, no performance parameters, and I mean none, nothing related to it. You should, and I also mean, when I say menu diving, I mean windows as well. You know, you shouldn't have to flip between envelopes. You shouldn't have to flip between wave shape and formant and this, that, or the other. If you've got a parameter that is for performance, it needs to be visible at all times. Otherwise, it's not a performance parameter, and it's not an instrument, it's an interface. Instead, menus are great, though. And I don't know why, if you're going to put all this menu crap in, why is your manual not in your menu? Well, I don't want to install that. Well, no. You can put it in. It's like 3 pages. It'll be fine. It should be great. It's a great opportunity for supplemental information without sending people to some website on a link from the README or whatever. Right here, you can see I have a brief introduction to Pulsar synthesis. Look at the ARP 2600 manual. They talk about... Nuclear does put a good explanation of Pulsar synthesis, and I guess Rhodes basically wrote a million manuals in microsound and computer music tutorial. You get the idea. Here, you can see I have a dictionary of parameters, so you can know what each parameter does. And then this, it exists in synthesizers. It's always a little hidden, though. A start fresh reset function to just get me a new clean slate. All these things have helped me a lot, particularly the start fresh in experimentation and composition. And I know you can just delete it and put a new one on, or whatever. No, but just having the button's pretty nice. Another optimization would be the way we approach parameter association. One parameter, one slider. We've kind of discussed this a little bit. No global parameters as well. I want it to be very clear what you're controlling at any time, and you're controlling one thing. And that's why I put in, few enough things that I might be able to do all 10 parameters at once, or maybe not quite. Maybe I got to use an elbow, but it should have a very literal naming scheme too. So here, the form and the formant, form and form 2, it's abbreviated, but I think it's pretty clear that is the formant frequency. Because I was going to say pulse rate, but I thought even that might be a little bit unclear. This is the formant frequency, and that is what it's going to sound like. Allow me now to pitch you my idea, my principle, my philosophy of device state visibility. Crafting devices that look the way they sound. So take a look at these 2 parameter states and answer these questions to yourself. Of these 2, which setting will be crazier? Yes, I mean semantically. Crazier. Which setting will be more precise? Which setting will be noisier? Which setting will generate more random values? I think you know which one it is. It's the one on the right, obviously. It's more colorful. It's more vibrant. You can see the ranges. You can tell that Form 1 has a smaller range than Form 2. Maybe a little bit messy because of the scaling of the logarithmic scaling, but no, you can tell. All these things are available at a glance, which is what is necessary for performance. You can tell how high you are up on the neck on a guitar. You can tell you're reaching way over to the side on the piano. You can tell if you're jamming on the drums because you're just sweating your butt off. But Like, all these things are inherently intuitive. We just take them for granted, but that is something that happens in the real world that we need to bring to the digital world. So let's look at the criteria for device state visibility. Sonic change should be reflected visually through the user interface. As you change a parameter, so too does the visual representation of that parameter. And yeah, I mean, just the slider knob does it, or like slider rotary fill or whatever, but let's go above and beyond that. Menu diving, and this includes window diving too, of non-performance parameters only. So every wavetable synth I've ever used, you don't look at all the envelopes at once. Actually, well, this isn't, it's a FM synth, but FM8, I think, does have a pretty nice envelope system to look at them all, absent to them, listing only native instruments, of course, but let's do better with that. I don't want to have to dig through to play an instrument. It should just be apparent. Limit the parameters to only what a user could reasonably use at one time, because this is the instrument. It's not a DAW. You know, it does its thing. It doesn't do a bunch of things. It does its thing. And we have plenty of plugins out there. They don't need to be a one-stop shop. And we want predictable results. Like I showed previously, you should be able to look at an instrument and say, oh, this thing's hot right now. It's ready to go. It's going to make a bunch of random values. Or, oh, this one's ready to be sharp and crisp and a little quiet too. All right, so how does this happen in Pulsar? Sonic and visual relationship. You can see the ranges change. You can see the opacity and weighting change with it. The wave shape is always visible, and you can see that change as it is interpolated or randomized. And the amplitude coefficient, the amplitude is multiplies the brightness of the wave, so we can see it get dimmer as it trails out. Menu diving should be reserved for tutorials, maybe a reset function, presets, and if you're gonna do a mod matrix, it's basically a menu. You're menu diving for it. So don't, just because it's visible doesn't mean you're not menu diving in some way. If you have to go through windows, that is. Limit the parameters. So in my case, I abandoned a couple types of envelopes. One, just the detailed things like Pulsar generator, where you can draw in parameter changes over time, because I figure, hey, we got automation for that within a DAW. And then two, I did eliminate the envelope shaping of each pulsarette. I just embraced it. I think I want there to be a signature tone of Pulsar. Maybe I'll make an interface in the future that does give that kind of detailed control. But for performance sake, I think it's better to not have to worry about that. And it needs to have predictable results too. So I mean, talk about this. Pan, why is pan the only horizontal one? Because this is more intuitive for left to right than this. Right? So that's why panning is horizontal. You know, make that kind of adaptation is something that I believe we should do. Let's draw some historic parallels here. So that way we can have a future informed by the past. I don't know why I wrote that. If you're a synth head, you'll know the story of East versus West synthesis. And on the left, we have a Buchla setup. Lots of cables, lots of modulators, crazy sounds, more academic, very West Coast, hippie, crazy new art stuff. I love that. Don't get me wrong. I love Eurorax. I love this kind of synthesis, right? But there's something different about a Moog. And there's a reason why Moog is credited with making it so popular. And we saw Moogs in funk music, and we saw Moogs in film scores sooner than we did with Buchla type. And I put that quote down there again. It allows you to perform in a emotional, expressive, virtuosic sense. Whereas the Buchla is more of an experimental sense. And don't get me wrong, Moog has plenty of stuff that looks like the Buchla too. I was at their factory in Asheville, and holy cow, they had a rack that would blow your mind. But in general, I want to play that role. We have a lot of the West Coast type granular synthesizers. They're very variable. You can put anything into anything else. You can adjust ranges. They're not limited at all. I want limitations. At least in a performance virtuosic instrument, I want limitations. So Pulsar, I am proposing, is the Moog of particle synthesis. Recluse Audio will be the Moog of particle synthesis, because we have an abundance of, oh, that's someone actually emailing Recluse Audio. We have an abundance of academic interfaces for experimentation. We don't have expressive interfaces for the person who doesn't do the math. Not that they're incapable, but they just are not. They're making a sound design thing for a movie, in Wise, and it's going to be tomorrow. It needs to be done, right? So, and they just want to experiment. They want to do it with touch. And at the advent of these NKS protocols and machine and all these controllers, I think it's ideal for this type of to fit this category. So in conclusion, there's a couple things and messages that I determined, like, I need to do this for Pulsar to work. I needed to sacrifice some precision. I can't control every single parameter. I just needed to control some. I needed to limit envelopes to only the essential trajectories, which really is amplitude in my case. I wanted to remove mod matrices. I am the mod matrix. I am the mod now. Look at me. I choose to design devices that reflect multiple parameters at once. And not only reflect them, but like are perceivable. You can perceive multiple parameters at once. Any performance parameter that directly affects sound will be visible and at the fingertips of the composer at any time. This is essential in a performance instrument. This is a little statement about my company at Recluse Audio. We are committed to 5 things. Deliver kindness and support to users above all else. Worry more about quality service and less about licensing and authorization. Create devices that do one job well. Serve artists old and young of all demographics, of all identities. And share what we have learned through open source when we can, through helping other people and troubleshooting with customers. You can follow me on TikTok, Instagram, or YouTube. My silly stuff is on TikTok, of course. You can email me at artie@recluseaudio.com. You can visit recluseaudio.com. I do have some free software. I want to thank 3 groups in particular. Dr. John Thompson, I wouldn't know anything about C++ without him. And then everyone at Georgia Southern and Dr. Olson for sending me there. They've been so much help and really appreciate it. Obviously, Josh, everyone knows Josh. Speaking with him independently, I mean, he's the only one who's doing this. He's the only one who's helping everybody. And him and the Discord mobs from Daniel Foley and Ayal Amir and Xenakios and Timur and everybody who's presented with him and shared their information. I really appreciate it. And all the online contributors, I guess this goes into the mod group. The Juice Forum, man, and granted, that's mostly the audio programmer mods. You look 10 years back and it's still Daniel. But people who make content like this, people who release open source technology, people who share their code and share their ideas, it's really invaluable, and I really appreciate it. I hope I can contribute in the way that you have. So thank you very much. If you have any questions, let me know. This would be the time. I'm happy to expand on any part of Pulsar synthesis or just selling plugins in general. Thank you. Again, my name is Ryan Devens, Recluse Audio.
All right, there you go. That is the fixed media portion of my presentation. If we have time for questions, I'd be happy to take any. Otherwise, I'll be roaming around Gathertown in all yellow. So
we've got some questions here.
Excellent.
I don't think it was featured. Is this on? Can you hear me?
Yes, I can.
I wondered if you might be able to explain to me how you achieve convolution with Pulsar trains. I know it's in Curtis Rhodes' book, but I don't know how to do it.
Yeah, that is one that I didn't do in the real time with the for Pulsar. So my extent of understanding of it is that you are convolving an input source with the wave shape. So you can form it based on the spectrum of the wave shape. I mean, just take my voice and then emphasize the sawtooth harmonics of odd and even harmonics or whatever type of wave shape you use. It then is rhythmically affected by it at the same time. So it's almost like a ring modulation or an amplitude modulation where it will kind of spit and sputter with the Pulsar train. But that's not one I've implemented, though. That's just one that was one of the sacrifices I had to make because I'm like, I don't know if I could even conceptually assuming it was running perfectly. I don't know if I could conceptually do that in real time. And I didn't want to have to use a delay line for it. I don't think I would necessarily need to, like I would a granulator, but yeah. So we could talk offline about that. I don't want to speak out of turn. I'm not an expert on that application of it as much.
Yep, that's still helpful. Thank you.
Yeah.
Hi.
Hello.
You're talking about the getting kind of the performance experience with it. Have you thought about kind of taking it to dedicated hardware? Because with you've got all your kind of nice layout in the plugin design, but if you're still kind of assigning things to knobs, they're still kind of limited by what's there physically with performance.
So you're talking about building my own like or hardware synthesizer of this? Oh, I would love to.
Either as an embedded thing or as a kind of dedicated controller.
Yeah, I would really love to. And in fact, I'm finding just in creating content, like there's such a developed audience for people going DAW-less. I was working with someone on a looper for, I don't know if you've heard of Elk Audio. You can do embedded C++. It's basically a standalone DAW computer. That's still pretty novel. And that was something I considered for Pulsar. And I think this would do totally fine. I just don't have as much experience with embedded software, but I would definitely love to do it. If anything, it would accomplish the goal just as well. I will say that I like using it in a DAW. And when I perform live, even when I'm doing, old timey jazz, playing piano, I play with a DAW. And so, at least for this particular sprint, we'll call it, use the agile term, this particular goal, I did want it to be in a DAW, but this would be something that would go really well. Plus the whole aesthetic, Heinbach talks about test equipment synthesizers all the time. You could just put it in like a brutalist box with some like really heavy duty knobs and it would feel like it's out of post-war Germany. It could be really cool. So I would be interested in doing that. It's just, taking all the steps to accomplish that.
Yep.
I think it would do very well in that setting. Yeah, taking questions online too, if anyone has them. Otherwise, I'm happy to answer them in person too.
Great. Can we all give a round of applause for Ryan?
Thank you so much for checking it out.